In this video, we are going to look at unions and intersections involving the empty set or the universal set, and this is from the Problem Solving and Set Theory module. They give us subset B and the universal set U right here, and they're defined as follows, and they want us to come up with the following sets. They want us to find the intersection of subset B and the complement of subset B. Then they also want us to find the union of subset B and the universal set. So to begin, let's start out and make sure we know what the complement will be of subset B. And the complement is going to be what's not in set B. So if we compare the universal set to subset B, we can see that the 3's match up, the 5's match up, and the 8's match up. So the complement to set B will be the remaining numbers 4, 6, and 7. So I'm going to make that subset right here, 4, 6, and 7. Now in part A, they want us to find the intersection of subset B and the complement of subset B. Now, the intersection, I want to remind you, intersection is going to be a set of elements from the universal set that are in both subset B and the complement. Okay, so if we look at this and we were to compare and we were to look at 3, 5, and 8, and we're looking for the intersection of that with the complement, which is 4, 6, and 7. And if we are looking for something that has to be in both of them, well, because they're complements of each other, there's not going to be a number that's in both of them. The 3 is only in this list, it's not in this list. The 4 is in this list, but not in this list, and so on. So what actually happens here for part A is we end up with an empty set, and we can use this particular symbol to indicate the empty set. So there is no number that is going to be in both subset B and the complement of subset B. So that's our answer for part A. Now let's take a look at part B. Comparing subset B to universal set U, we're looking for the union in this case. So let's write that out. We have 3, 5, and 8, but we're now looking at a union between the two. And the universal set was 3, 4, 5, 6, 7, and 8. And I just want to remind you that for a union, it's a little bit different than it was for an intersection. For a union, it needs to be in subset B or subset U or both. So if it's in either one of them, we consider it part of the union. So what happens here is, yes, they both have the 3 and they both have the 5 and they both have the 8, but we also have some additional numbers 4, 6, and 7, and as long as it's in one of them, then we consider it to be part of the entire union. So the answer is that we're actually going to have a list that has all of these values, 3, 4, 5, 6, 7, and 8. And our answer is actually the universal set. And so that's okay. We will just type out all of these numbers for our answer for part B. So I hope this helps to better explain unions and intersections involving the empty set or the universal set.